21st century. Bringing in the harvest is a hyper-speed marathon. From the fields and orchards to the caves, it's a symphony of precision picking, sorting, and packing. But where does the human hand end and the machine begin? Now, Harvesting 2 on Modern Marvels. Every year from spring until fall, California's fruit harvest is in high gear. At Roymer Farms in California's San Joaquin Valley, they're picking nectarines. For all growers, stretching the harvest season means raising different varieties of the same fruit.
We have varieties planted specifically throughout the different times of the season to fulfill those different time slots for providing fruit to the marketplace. So a typical variety of nectarines may harvest for 2 to 3 weeks.
A good harvest depends on fruit that looks and tastes its best. To add maximum appeal to a nectarine, most growers line the orchard rows with strips of mylar. The reflective surface concentrates the sun's rays into the tree canopy, promoting photosynthesis and increasing the sugar content and color quality of the fruit.
And that's when the fruit's actually going through its sizing process. It's when it's developing its sugar, developing its color. And so we're trying to maximize its environment during that particular critical time point before harvest.
As the workers begin picking, growers will spot check the fruit to verify their decision to start harvesting.
So what we'll do when we're trying to decide whether we're harvesting properly is we'll sample them with the penetrometer to see what the flesh firmness is to determine whether we are picking the level we want. So we just quickly shave a piece of the skin off, and then we use this plunger to push in there, and the force that it takes to push that in will then determine the flesh firmness. This one rated at 11.
Picking is no longer the last step in the harvest. In many cases, it's just the beginning. Ito Packing Company is one of the largest fruit packers in the country. The 10-acre facility operates 3 state-of-the-art packing lines for boxing peaches, plums, blueberries, apples, and many other fruits. Today, it's nectarines and pomegranates. In one shift, the workers can pack up to 120,000 boxes of fruit on 2 lines. All of it sorted according to size, color, and degree of ripeness.
We become almost the warehouse for the grocery stores, so they'll give us an order and give us only like a 1 or 2 day lead time to pack it, put it on a truck, and get it over to anywhere in the United States.
After it's picked, a piece of fruit has a limited lifespan. Sophisticated post-harvest handling is a way to stall for time. At Ito, the race to preserve freshness starts with a cold shower. The hydro cooler pours frigid 32-degree water over the fruit to reduce its internal temperature and slow down decay.
This is absolutely crucial in maintaining good quality. In the harvest season in California in the summertime, our temperatures can be well over 90 degrees Fahrenheit, even 100 degrees Fahrenheit. And the fruit will lose quality quite quickly, will dry and lose sugars.
The cooled fruit quickly makes its way onto the sorting line for a quick wash and wax. After it's rinsed, it's sprayed with a vegetable oil product to help prevent moisture loss during the long journey to the supermarket. Before sizing begins, inspectors use their highly trained senses to remove the subpar fruit.
As they touch it, they're looking for a soft shoulder or soft tip on the fruit that would bruise or damage easily and could later decay in transit. So that piece of fruit that's a little bit too soft is then removed.
The rejects are diverted and will later produce juices, jams, and other processed products. The fruit that passes inspection continues its journey to the high-speed sorting line. For centuries, farmers have sorted fruit to achieve uniform shipping weights and to satisfy consumer preference. The first packing houses used crude sizers with wooden slats or holes through which the smaller-sized fruits would drop. Today, the optical fruit sizer is a faster, more accurate method. The fruit is first diverted onto a single-file cup conveyor, moving at about 10 pieces per second. As it passes into the sorter, each piece is rotated and photographed by 2 lenses. An infrared lens gathers shape and dimensional data, and a color lens collects the color qualities of the fruit. The camera quickly snaps 25 photos to create a 2-dimensional projection of the entire fruit. From this picture, the computer interprets its exact size, shape, and color.
Now we've got a full look at it, and then we can determine if the amount of color that we see, red versus yellow, is the appropriate color that's desirable for packing. And that's helpful in markets where we want to send fruit of a uniform size, color, and shape.
Once the computer obtains the mug shots of a certain piece of fruit, a timing device triggers a lifting finger that deposits the fruit into a specific lane according to size and color. This high-tech sorter delivers near-identical fruit to each of many packing lines. After a final human inspection, the fruit is hand-packed in a variety of boxes.
Then it's conveyed by forklift into a cold storage room where it's stored at an ideal or optimum temperature that actually puts the fruit to sleep. Once the fruit is in that condition or in that state, it's in the best environment to be transported from California to the various markets in the Midwest or the East Coast.
The packing house can even hold boxed fruit at a higher temperature to force ripening. Sophisticated post-harvest handling of fruit is a progression in a ritual that has remained otherwise unchanged over thousands of years. This Egyptian tomb drawing, dated at 1900 BC, depicts 2 workers harvesting a fig tree.
The key components of harvest are the same. One's picking the fruit and then putting it into a basket. The other is sorting the fruit and putting it into a consumer package. The practices involved in picking and packing are basically still the same and haven't changed.
Ancient Egypt is one of the birthplaces of horticulture. The first growers learned to irrigate their fields by tapping the Nile River's seasonal floods. But without modern technologies, these growers were faced with the problem of spoilage.
They didn't have refrigeration, they didn't have canning, they didn't have these other processes to preserve the harvested crop. So the crop had to either be consumed fresh soon after harvest or dried and stored dried.
China was the birthplace of temperate fruits, such as peaches and pears, more than 4,000 years ago. The Greeks and Romans oversaw a thriving fruit trade throughout the Mediterranean. When Mount Vesuvius erupted in 79 AD, the Romans were cultivating extensive orchards containing peaches, citrus trees, and grapes on its very slopes. During the Middle Ages, monks were the most sophisticated growers. They practiced the skills of tree grafting and crossbreeding to produce new varieties of fruit trees. The colonists brought Europe's fruit tree saplings to the New World. But the true American orchard revolution was again fueled by monks. As the Spanish moved north into California and established missions in the 1600s, the monks took advantage of the dry climate and raised large orchards of grapes, figs, peaches, pears, and apricots. As settlers moved to California in the 1800s, the orchards fanned out to supply the new urban centers of Los Angeles and San Francisco. Growers also planted in the Sierra foothills to feed the influx of gold miners. California fruit production exploded in the 1890s when refrigerated railroad cars allowed growers to ship fresh fruit to the huge East Coast markets. But in the coming decades, the small family-operated farm would nearly vanish.
Farms began to get bigger primarily because of competition. There's a continuing pressure to reduce the price of fruits and vegetables at retail market. And that means the farms generally have to get larger in size to take advantage of economies of scale.
Large vertically integrated growing and packing operations are now the standard in U.S. fruit production. Labor remains the most unpredictable and expensive cost a grower bears. The future status of an untold number of undocumented workers could have a tremendous impact on harvest costs. In the 1960s, engineers from the University of California at Davis began testing a multitude of mechanical fruit harvesters. Various tree shakers and shake-and-catch machines were very effective at harvesting fruit quickly. But the percentage of damaged fruit was unacceptable. Half a century later, there are still no commercially viable mechanical harvesters for picking many types of fresh fruit. One solution may be a man-machine interface that allows laborers to more efficiently access the tree canopy. Here, a pear grower and engineers from UC Davis are testing a modified European-built platform in Northern California. The machine offers 6 movable picking platforms at 3 different heights, allowing the harvesters to move laterally or up and down inside the tree canopy.
So the workers, instead of placing fruit into bags and delivering it to bins, would place fruit 2 or 3 at a time into little feeder conveyors that fed into a main elevator. At the top of the main elevator, the fruit would go into what's called a bin filler, where the fruit is lowered and placed into a rotating bin, which ensures even distribution of the fruit in the bin.
By eliminating the need to carry heavy ladders and picking bags, the platform might expand the potential workforce to include more women and older laborers. It could also improve worker safety and reduce workers' compensation claims from ladder falls, a major problem for many growers. The harvesting platform has already gained a firm footing in Europe, where hand labor has been in short supply for decades. In the American Midwest, one harvest has eliminated the human hand entirely and put the picking and packing house on wheels. California harvests more than 90% of the nectarines and plums grown in the United States and provides over 70% of all the peaches. Harvesting 2 will return on Modern Marvels. We now return to Harvesting 2 on Modern Marvels. In the Midwest, America's biggest harvest has eliminated hand picking and put the farmer at the wheel of a computer-controlled maximum efficiency machine. Nebraskan John Sandahl is harvesting corn in a John Deere 12-row combine. The air-conditioned cab may seem cushy, and combining corn may look a bit like mowing the lawn. But this harvest demands a sharp eye and fast decision-making.
While harvesting corn, we're scanning the corn head all the time, watching for objects in the field, make sure that all the row units are functioning properly, pulling the corn stalks down through. And this corner post monitors all the functions of the machine. The first one down here has the engine RPM, the speed that I'm traveling. The middle one is the grain loss monitor. That's very important. It keeps track, monitors how much grain the combine is losing out the back.
A small percentage of the harvested corn drops back in the field, and the operator minimizes these losses by slowing down when necessary. The modern combine is a factory on wheels. As corn stalks enter the corn head, a series of rollers pull down the stalks and snap off the ears. An auger moves the ears into the combine, where they're conveyed into the threshing mechanism. Here, a spinning rotor threshes the kernels, removing them from the cob, while a strong fan blows out the leaves and chaff. The kernels are then conveyed to the combine's holding tank. On Sandal's farm, the corn is offloaded onto trailers. The kernels are loaded into bins that will store the grain and complete the drying process. Corn is a crop with many uses. Everything from tortillas to corn syrup, animal feed and ethanol, a corn-based alternative fuel that is boosting demand across the Corn Belt. More than 7,000 years ago, it was a decidedly simpler crop. In the region that is now Mexico, natives began harvesting a wild grass called teosinte. Over thousands of years, the Mesoamericans domesticated teosinte by sowing and reaping only the best kernels. It evolved into a hardier, more productive plant known as maize or corn. After its first migration north in about 1200 BC, it would become the most important crop in American agriculture.
When the Pilgrims first arrived, they planted in small hills, several seeds in a hill. They grew the corn, they harvested the ears, and they ground it into flour.
In the colonies, and for centuries that followed, corn was harvested by hand. The corn knife with an 18-inch blade was one of the original methods of cutting the stalks. When farmers were picking only the ears, handheld hooks or pegs made of iron and bone were the standard tools.
This is a bone peg that was probably used in 1890. They used anything that was sharp to open up the shucks at that time.
Gloves with embedded hooks later replaced the peg.
People in rural communities are very innovative, and so they were always looking for some way to do it better, to do it faster. The hooks and pegs allowed for faster harvesting because they could rip the shuck away from the ear, snap it, and harvest it much quicker than just by hand.
Even today, many rural communities still celebrate the days of hand harvesting with husking bee competitions. Ted Morton is a former Nebraska state champion.
Well, you grab the ear towards the end like this and come in with the hook crossways, open up the shucks, then you peel them back and you snap the ear out and throw it. And it's all one motion, really.
A fast husker could generally harvest about 100 bushels or 1 acre of corn per day. Once the whole corn ears were dry, the kernels had to be removed. For decades, nearly every farm was equipped with a hand-operated corn sheller.
Okay, we've got a couple cobs of corn. We're looking at a hand-powered corn sheller that's about 100 years old, and we're going to run a couple cobs through it. First, I'm going to crank it up. A couple plates inside the machine going in opposite directions are going to shear the kernels off. The corn kernels go down the bottom. The corn cobs come out the other end. And there's a fan at the bottom that blows some of the chaff away as well.
Many farmers harvested corn for silage or animal feed. This included the stalk as well as the ear. Silage was the first corn harvest to see mechanization in the form of the corn binder in the late 1800s. On one Nebraska farm, Ron Lang operates an antique corn binder to harvest feed for his horses.
It's an international corn binder. It cuts it and ties it. And this mainly used to be used more for green corn and fill silos with it. They would cut the corn green and haul it in and fill your silos.
The binder both cuts and then automatically ties the stalks into bundles with twine. The operator uses a foot clutch to engage a conveyor that drops the bundles in the field. Corn binders were usually followed by a crew of laborers who stood the bundles into larger upright stacks, known as shocks.
The shocking is for your winter feed, and it would mold and stuff on the ground. And the shocking is for curing. You got to shock it so the wind goes through it.
Up through the Great Depression, the meticulous hand harvest was still the only way to pick the ears directly. The first mechanized corn pickers powered by internal combustion engines debuted in the late 1930s and would soon double productivity to 15 acres in one day. The pickers selectively harvest only the corn ears, depositing the stalks back in the field. Farmer Randy Jensen uses a two-row 1960s model 237 John Deere picker to harvest 600 acres of corn each year. The picker uses rollers to snap the ears off the stalks. The ears travel to a husking bed, where rubber rollers remove the husks. The clean ears then drop in a wagon.
When you come to the end, you'll have a full wagon most of the time, and you'll have a guy at the other end, and he'll switch wagons with you. And he'll take it home and run it to an elevator, which elevates it up into an ear corn crib. And basically that's all you do.
While the mechanical pickers endured for decades, they couldn't shell, clean, and dry corn on the fly. By the mid-1950s, there was an answer. The combine, which had long before mechanized the harvesting of other grain crops, was now advanced enough to produce clean corn kernels at a staggering pace. What began with two-row designs grew to the 12 and even 16-row corn head combines of the 21st century.
You're talking about the ability to harvest 4,000 or so bushels an hour, which translates to maybe 60 to 70 pounds of grain, clean grain, every second that this machine can harvest.
If we go back to working with a corn binder, we're talking about working maybe 8 acres a day, and now we're talking about hand picking, we're talking an acre or so a day, 100 bushels. Today's big farmers with large combines can do 40,000 bushels in a day with one combine.
The American corn harvest relies on the size, speed, and sophistication of one machine. But there is another uniquely American harvest that depends on a roll call of amphibious machines to beat, comb, and rake a colorful fruit into submission. The state of Nebraska alone produces some 1.2 billion bushels of corn each year. That's almost 300 pounds for every man, woman, and child in the United States. Harvesting 2 will return on Modern Marvels. We now return to Harvesting 2 on Modern Marvels. Every year in October, there is a fruit that must first go for a swim before it can be picked. Just days before harvesting, farmers in central Wisconsin divert water from nearby reservoirs in order to flood thousands of acres of cranberries in up to 2 feet of water. This is called a wet harvest. The berries grow on short vines. When they mature, the fields are flooded to make harvesting easier. These water reel harvesters, also called beaters, will transform the marsh into a sea of red.
The first guy that goes in the water is opening the bed, and then the rest of the guys behind him just keep following along behind him. What they're looking for in the water is what we call a berry line, where you can see where the fruit's been picked clean and where the remaining fruit is. So you try to line up on that, and the idea is to not miss any fruit and beat it clean or pick it clean.
As the beaters move through the vine, they strip off the berries. Cranberries contain 4 air chambers. When freed from the vines, their natural buoyancy causes them to float.
Cranberries are trained, meaning the vines lay a certain direction. A good analogy would be like petting a cat the right way and the wrong way. You pet it the right way, everything's nice. You go against the vines or against that cat, his fur gets all ruffled up and it's not a very nice thing. Same thing can happen with cranberries. If we go against the vines, we'd rip them out of the ground and it would be a mess.
Once the 3-acre bed is beaten, the workers deploy a cran boom to slowly coax the flotilla to one end of the marsh. Here, more than 80,000 pounds of berries are loaded by elevator and trucked out. At the Ocean Spray Receiving Station, the berries are offloaded into holding tanks. And then conveyed into the packing house, where they're cleaned and then sized. These cranberries are destined for processing, meaning they will end up as juice, sauce, or even craisins, the cranberry equivalent of raisins. But long before cranberry juice and craisins dominated the market, Native Americans understood the power of the fresh berries, using them in medicines, poultices, and dyes. Dried berries were even pressed together with venison and fat to produce pemmican, a survival cake that kept for long periods of time. The first commercial growers in the 19th century recruited cheap field laborers, often women and children, to meticulously hand harvest the wild-growing vines.
When the men, women, and children would show up on the cranberry marsh, they were given a measure. Once they had a full measure, they would go over to the edge of the bed, dump the measure into the receptacle, and that picker was given a picking chip. That picking chip would be used for either cash or merchandise at the company store.
In the 1890s, the first cranberry hand rake replaced the picker's calloused fingers and quickly became the harvesting method of choice. Growers eventually discovered that flooding the cranberry beds made hand raking much easier.
This is the hand rake. It's got metal teeth with slots in it. As you rake, you go through the berries, through the vines like that. The berries are floating on top of the water. They're attached to the vines, but you still got to take them off. And it's a back-breaking job if you have to do it all day long, especially if the vines aren't trained.
In the 1950s, Wisconsinite Leonard Getzinger designed one of the first successful mechanical harvesters. The hand-pushed Getzinger picker uses retractable metal teeth to comb through the vines and pick berries. Up until the 1970s, the majority of all cranberries were sold as fresh fruit for traditional cooking.
During the 1970s and 1980s, the juice market exploded, and the demand for cranberry juice far exceeded the demand for fresh cranberries. The whole industry shifted from fresh fruit to processed fruit.
Most farmers began wet harvesting with beaters to bring in a larger, yet less carefully handled crop. But one man feels there is still a better mousetrap for farmers who raise cranberries for processing. It's called the Ruby Slipper.
Well, it's a machine I started working on it about 7 years ago, trying to find a simpler, faster method to harvest cranberries that was easier on the fruit, easier on the vines. This is a lot gentler. The bar itself is traveling at a slower speed when it contacts the vine, but the ground speed of the machine is a lot faster.
The ruby slipper is pulled through the marsh and requires no moving parts to remove the cranberries. Regardless of the machine, harvesting cranberries for juice or craisins is not a gentle affair. But there's another harvest, more steeped in tradition, that demands a more delicate touch. Habelman Brothers in Tomah, Wisconsin is the world's largest producer of fresh cranberries. This harvest is all about delivering the perfect berry. Habelman's harvesters utilize stainless steel teeth to comb the vines, much like the original Getzinger pickers. But these more gentle modern harvesters use a series of paddles to free the berries from the vines.
The berries never end up back in the water. They go right into the boats and then into the trucks. We can do about 10 acres a day with the 2 machines that we're using right now.
When it's time for packing, the berries go through a separator line to remove discolored and poor quality berries. At the front end is an antique device that has never been upgraded or redesigned, the Bailey separator. Invented by the H.R. Bailey Company in 1917, it was conceived with the idea that only fresh cranberries will bounce.
So they pass through a series of boards. Good ones jump and land on a finish belt. The bad ones just kind of filter down the machine. And a lot of companies have tried to come up with a better design, but there isn't any out there yet.
The cranberries that pass Bailey's tests are then double-checked by more modern equipment. 2 different electronic separators use ultraviolet and fluorescent light to detect inferior color and rot. After the antique and high-tech separators have their go, the final quality check is human. Any bad berries that have survived the gauntlet are weeded out before packaging. As the demand for healthier food and drink continues to spiral, a wild assortment of cranberry harvesting machines will continue to prowl the marshes of central Wisconsin. But picking berries in the Midwest autumn at low altitude is a picnic compared to a hot, dangerous head-in-the-clouds harvest, where one mistake could be fatal. Growers in the state of Wisconsin harvest more than 50% of the United States cranberry crop. Harvesting 2 will return on Modern Marvels. We now return to Harvesting 2 on Modern Marvels. In the low desert of Southern California's Coachella Valley, there's an annual ritual that is perhaps the most dangerous harvest in America. This man is a palmero. His job is to harvest dates from trees that can grow to heights of more than 80 feet. Date grower Dennis Jensen speaks of the industry's anxiety over the latter harvest.
It's dangerous work up there. One slip and they could end up in a world of hurt. As much as we try safety-wise, it seems that every other year we lose someone to this terrible tragedy. Some of the other items that are very dangerous are the spines, the palm fronds themselves that can pierce your hand or an eye or an arm or a leg or foot. And they're located throughout the crown of that tree. So there's a lot of different dangers that they have to work with.
The palmeros in this field are hand harvesting a premium date, known as the medjool, one of several date varieties that have been cultivated since before recorded time. Dates are likely the oldest of all harvested fruits. Nearly 6,000 years ago, they were cultivated in the region of Mesopotamia, or what is now modern Iraq. Some traditions trace the fruit to the Garden of Eden.
even the Bible refers to the land of milk and honey, and we've been told by Jewish scholars that the honey it was referring to was the honey of the date palms.
Its ability to grow and produce fruit in such an arid environment made the date palm a sacred tree.
Dates keep very well, and in that hot desert area where they had no refrigeration, they could keep them for a long time. And early on, they discovered the ways to press them together to get rid of air and so forth so that they would keep.
After many failed attempts, date palm offshoots were successfully imported and planted in the Arizona desert in the year 1900. The coveted medjool offshoots came from Morocco in 1927 and were later planted in the Coachella Valley. Today, California growers of medjools and the other major variety, the Deglet Nor, oversee a thriving industry that annually harvests a crop worth around $50 million. But times are changing for the skilled palmeros. Most date growers are relying less on the ladder harvest and more on a mechanical harvesting aid, the canasta. Mounted on a 9-ton lift, the platform opens and closes around the date palm's trunk. Even as mechanization makes the work safer and easier, the job still requires a trained palmero to distinguish dates that are ripe for picking.
Normally what they're going to do is they'll be looking for the ripest ones, and they're pretty easy to pull off. And sometimes you can just shake them and they'll actually fall off of the bunches. But they'll be pulling out the ripe ones, which are the darker color ones. There's yellow ones on here, which are not ripe yet. It'll take another probably 2 to 3 weeks before they will ripen up.
Prior to harvesting, the palmeros wrap each and every growing date bunch in a nylon bag.
Our date bags are used to keep moisture away from the dates should we have a sudden thunderstorm, and the rain and moisture causes a lot of decay for the dates. Additional purposes of these bags are to keep insects away and to keep birds from eating the dates.
To prevent damage to the delicate fruit, harvesters lower small baskets to the ground, where they're hand-sorted for ripeness. After a short journey to Dennis Jensen's Seaview packing house, the dates are cooled. Then they're carefully washed and dried before they're hand-sorted for packing. One of 5 quality categories are assigned before the dates are shipped to points around the world. While dates are harvested in scorching 100-degree sunlight, there's another crop that prefers the cool darkness of the world's largest underground fungus farm. The date palm tree is considered so beautiful that as many as 15,000 trees are harvested and sold each year to real estate developers. Harvesting 2 will return on Modern Marvels, here on the History Channel. We now return to Harvesting 2 on Modern Marvels. Deep within the rolling hills near Pittsburgh, Pennsylvania, directly beneath the trees and pasture land, more than 800 acres of limestone tunnels play host to the world's largest mushroom farm. At Creekside Mushrooms, more than 150 miles of tunnels in a former limestone mine are a fungus farmer's dream.
The neat thing about growing mushrooms at this particular facility is that the temperature is pretty much consistent all year round. And we maintain about a 62-degree temperature all year round and about a 95% humidity, which allows mushrooms to just recycle themselves pretty much every 24 hours.
Creekside's fungus of choice is the Sylvan White Agaricus, the ever-popular white button mushroom. Each day, a small army of harvesters speeds from one cave to the next. Each worker aiming to pick a minimum of 55 pounds per hour. The mushrooms are grown in and harvested from large wooden trays. Each tray is harvested in passes, or breaks. The first break yields the large and medium mushrooms. Removing the larger fungi allows more room for the smaller mushrooms to grow and develop.
I'm picking the mushrooms that are ready at the prime time for harvest, and that depends upon the stem length, the shape of the cap, whether it's domed or oval. If you notice, the only smalls that I take are the ones that come off basically by accident. They're left on there for tomorrow. There'll be mushrooms that will be harvested again tomorrow.
Each tray ultimately yields approximately 250 pounds of organic mushrooms. But not every mushroom is perfect.
This mushroom in particular has a blemish on it. That is what we consider a number 2. It would not look as nice when it hits the supermarket.
The popular white agaricus mushroom was first domesticated in the cellars and sewers of 19th century France. The process of producing the spawn, or seed, was the key to growing the fungus commercially. After the French perfected a strain of spawn, it was soon exported to England, and ultimately to the United States. The mushroom business took off in 1904, when the United States Department of Agriculture perfected a domestically bred spawn, one of the very same strains that are used today. Even with a healthy spawn, profitably growing mushrooms in vast numbers is a very demanding craft. The process begins with piles of hay, straw, and manure. At Creekside Mushrooms, this compost is turned, adding water and fresh air to speed up decomposition. The compost is then pasteurized in a fresh air tunnel system.
It kills all the other microorganisms that are in the compost, so that when we do plant the spawn or the mushroom seeds into the tray, it gives a nice clean medium for the spawn to take hold inside the compost.
Each tray is filled with compost, and the spawn is then added. The trays are transported deep in the pitch-dark limestone caves to begin coaxing the root structure, or mycelium, to the surface. This tray of organic white agaricus will begin harvesting around day 15. Its mini mushrooms travel to Creekside's packaging facility, where they're weighed, packaged, or sometimes sliced before they're cooled and quickly shipped to market.
We don't get a whole lot of lead time, nor do we want a whole lot of lead time, because what we produce today, we want to make sure we ship within the next 24 hours.
While the mushroom harvest may seem stable, its future is not.
People that get out of high school today look for other opportunities, so it gets harder and harder to find labor. Labor holds us back from expanding. Right now, we grow about 26 million pounds. We'd like to be 30, 35, but our restraint is we can't get labor to get us to where we want to be.
Creekside's mushrooms are not the only crop impacted by a lack of labor. The trend is affecting harvests across the nation.
There's certainly less labor available. It began several years ago, but the increased pressure to reduce illegal immigration across the southern United States border has influenced the amount of laborers that are available for harvest.
As workers become scarcer, mechanization will play a larger but probably still restricted role in the harvest.
Labor is the most important factor in this business. When you look at the fragility or the nature of the fruit, this is not something that is conducive to mechanical harvesting. We rely very heavily on a labor force that's skilled to discern fruit quality on the tree, and there's really no other way to go about doing that.
Surely our machines will become more sophisticated and sensitive, and a declining labor force will spur that mechanical innovation. But only time will tell if the machine will ever match the human hand's ability to delicately pluck at unblemished